Download this code from codegive.com, link in the description below. Effective strategies for handling browser timeouts in API requests. Browser timeouts in API requests are a common source of frustration for developers. They can lead to unpredictable behavior, lost data, and a poor user experience. Understanding why they happen and implementing robust strategies to handle them is crucial for building reliable web applications. This tutorial will explore the causes of timeouts, different strategies for handling them in the browser, primarily using JavaScript and the Fetch API, and provide code examples to illustrate each technique. Understanding browser timeouts. A timeout occurs when a client, typically a browser, doesn't receive a response from a server within a predetermined amount of time. Several factors can contribute to this. Network congestion, high network traffic, either on the client's end, within the internet infrastructure, or on the server's network, can delay the transmission of requests and responses. Server overload. If the server is overwhelmed with requests, it might take longer to process and respond, leading to timeouts. Complex server-side processing. Long-running tasks on the server, example database queries, complex calculations, can delay responses. Client-side issues. Problems with the client's network configuration, firewall rules, or even the browser itself can cause timeouts. Incorrect URL or DNS resolution. If the URL is incorrect or DNS resolution fails, the request might never reach the server. Firewall or proxy issues. Firewalls or proxies can sometimes interrupt or block requests, resulting in timeouts. Resource constraints on the client. The client device may have limited processing power or memory, impacting the ability to handle responses quickly. Explicit timeout configuration. The browser or the code making the API request may have an explicitly set timeout value. This is often the most relevant factor we can control directly in our code. 2. The default browser timeout. Most browsers have a default timeout setting for HTTP requests. This setting is usually not configurable by the web page's JavaScript code. This default timeout can vary between browsers. While the exact value isn't strictly standardized, it's commonly around 1 to 2 minutes, 60 to 120 seconds. However, you should not rely on this default consistently. 3. Handling timeouts with the Fetch API. The Fetch API in JavaScript provides a modern and powerful way to make HTTP requests. While the Fetch API itself doesn't have a built-in timeout mechanism, we can implement it using abort controller and promise.race. Using abort controller and promise.race. This is the recommended approach for handling timeouts with Fetch. Abort controller allows you to signal a request to be aborted, and promise.race allows you to race the fetch promise against a timeout promise. Explanation *. 1. Fetch data with timeout, URL, options equals, timeout equals 5000, function *. Takes the API URL, options object, for fetch configuration like method, headers, etc., and an optional timeout value, in milliseconds, as arguments. The default timeout is set to 5 seconds. 2. Abort controller *. Const controller equals new abort controller, creates an abort controller instance. Const signal equals controller.signal, retrieves the signal associated with the controller. This signal is used to abort the fetch request. Options.signal equals signal, adds the signal to the fetch options. This tells fetch to listen for abort signals from the abort controller. 3. Timeout promise *. Const timeout promise equals new promise, resolve, reject, equals, creates a promise that will resolve after the specified timeout. Set timeout, equals, timeout, sets a timer. When the timer expires, controller.abort, calls controller.abort, which signals the fetch request to abort. The fetch promise will be rejected with an abort error. Reject, new error, request timed out, rejects the timeout promise itself. This is important so that promise.race knows the timeout has occurred. For promise.race, fetch, URL, options, timeout promise, asterisk. Promise.race takes an array of promises and resolves or rejects as soon as any of the promises in the array resolve or reject. In this case, it's racing the fetch promise against the timeout promise. If fetch resolves first, i.e., the API call succeeds before the timeout, response will hold the fetch response. If timeout promise rejects first, i.e., the timeout occurs, response will be the error request timed out. 5. Error handling asterisk. The try, catch block handles potential errors during the fetch operation. If error.name equals abort error, specifically checks for abort error, which indicates that the request was aborted due to the timeout. The catch block provides a place to handle different error scenarios, timeouts, abort error, HTTP errors, example 404, 500, and other potential issues. Critically, the throw error rethrows the error so the calling function can also handle it, example for retries. 6. Example usage, call API function. Demonstrates how to call fetch data with timeout with a specific URL, options, and timeout. The try, catch block in call API handles potential errors returned from fetch data with timeout, including timeout errors. You can customize the error handling logic to retry the request, display an error message, or take other appropriate actions. B. Why abort controller is important asterisk asterisk. Without abort controller, even if your code catches the timeout error, the browser might continue to wait for a response from the server. This wastes resources and can lead to unpredictable behavior. Abort controller actively cancels the underlying network request, preventing further waiting. 4. Alternative, less recommended, timeout strategy, set timeout directly with fetch. While using abort controller is the preferred approach, you can achieve a similar effect with set timeout directly, but it's generally considered less robust. Why this is less recommended asterisk. Doesn't actually cancel the request asterisk. The fetch request might still be ongoing in the background, even after the set timeout rejects the promise. This wastes resources. Abort controller explicitly cancels the request. More difficult to manage resources asterisk. You have to manually manage the timeout ID and ensure that clear timeout is called in all possible scenarios, successful response, error during fetch, etc. The abort controller approach is cleaner in this regard. V. Implementing retry logic. When a timeout occurs, a common strategy is to retry the request, especially if the timeout is due to transient network issues. Here's an example of how to implement retry logic with exponential backoff. Explanation asterisk. 1. Fetch data with retry, URL, options, max retries, initial delay, timeout, function asterisk. Max retries, the maximum number of times to retry the request. Initial delay, the initial delay, in milliseconds, before the first retry. Timeout, the timeout for each individual request, using fetch data with timeout. 2. Retry loop, while loop. The while loop continues as long as retry count is less than max retries. 3. Fetch data with timeout call asterisk. Inside the loop, fetched data with timeout is called to make the API request with a timeout. For error handling within the loop asterisk. If error.name equals abort error, error.response and error.response.status equals 500, checks if the error is a timeout, abort error, or a server error, status code 500 or greater. You might customize this condition to retry only on specific error types. Important, retrying on all errors can be problematic. For instance, retrying on a 400 bad request error will likely just result in the same error again. If the error is retryable, retry count ++ increments the retry counter. Const delay equals initial delay asterisk math.pow, 2, retry count, 1, calculates the delay using exponential backoff. This means the delay increases with each retry, example 500 milliseconds, 1000 milliseconds, 2000 milliseconds. Exponential backoff helps avoid overwhelming the server if it's already under load. Await new promise, resolve equals set timeout, resolve, delay, waits for the calculated delay before retrying. 5 non-retryable errors asterisk. Else. Handles errors that should not be retried, example 400 bad request. In this case, the error is rethrown to signal that the request has completely failed. 6 maximum retries reached asterisk. If the while loop completes without a successful response, i.e., retry count reaches max retries, an error is thrown to indicate that the request has failed after multiple attempts. 6. Strategies for minimizing timeouts. While handling timeouts is important, preventing them in the first place is even better. Here are some strategies. Asterisk optimize server-side performance asterisk. Asterisk database optimization asterisk ensure database queries are efficient and properly indexed. Asterisk caching asterisk implement caching mechanisms, example using Redis, MEMC8, to reduce database load. Asterisk code optimization asterisk profile your server-side code and identify bottlenecks. Asterisk load balancing asterisk distribute traffic across multiple servers to prevent overload. Asterisk asynchronous tasks asterisk move long-running tasks to background queues, example using Celery, RabbitMQ, so they don't block the main request thread. Asterisk optimize API design asterisk. Asterisk pagination asterisk if your API returns large data sets, use pagination to break the data into smaller chunks. Asterisk data compression asterisk use data compression, example gzip, to reduce the size of API responses. Asterisk WebSockets asterisk for real-time updates or bidirectional communication, consider using WebSockets instead of HTTP polling. Asterisk improve network connectivity asterisk. Asterisk content delivery network, CDN use a CDN to cache static assets closer to users, reducing latency. Asterisk optimize DNS resolution asterisk ensure your DNS configuration is optimized. Asterisk use web workers asterisk. Asterisk offload computationally intensive client-side tasks to web workers. This prevents the main browser thread from blocking, which can contribute to timeouts. Asterisk monitor API performance asterisk. Asterisk use monitoring tools, example New Relic, Datadog, to track API response times and identify potential performance issues. Set up alerts to notify you when response times exceed acceptable thresholds. Asterisk provide user feedback asterisk. Asterisk if a timeout occurs, display a user-friendly message explaining the situation and suggesting possible actions, example retrying, checking network connectivity. This helps improve the user experience. Asterisk tune timeout values asterisk. Asterisk carefully consider the timeout values you set for your API requests. Choose values that are long enough to accommodate normal server-side processing but short enough to prevent users from waiting indefinitely. Asterisk implement heartbeat/keep alive mechanisms asterisk. Asterisk for long-lived connections, example WebSockets, implement heartbeat or keep alive mechanisms to detect and handle broken connections. 7. Example, integrating a loading indicator. Timeouts can often lead to a poor user experience if the user is left waiting without any feedback. Displaying a loading indicator can help manage expectations. Here's how you can integrate a loading indicator into the call API function. Explanation asterisk. 1. Get the loading indicator element asterisk. Const loading indicator equals document.get element by ID, loading indicator, retrieves a reference to the HTML element that you're using as a loading indicator. Make sure you have this element in your HTML. 2. Show the loading indicator asterisk. Loading indicator.style.display equals block, sets the display style property to block, making the loading indicator visible. 3. Finally block asterisk. The finally block ensures that the loading indicator is hidden regardless of whether the API call succeeds or fails. This is crucial to prevent the loading indicator from getting stuck on the screen if an error occurs. Loading indicator.style.display equals none, hides the loading indicator. 8. Testing timeout handling. Testing your timeout handling is essential to ensure that your application behaves correctly when timeouts occur. Here are some strategies. Asterisk mock the API asterisk use a mocking library, example jest.fn, Sinon.js, to simulate the API and control its response time. You can create a mock API that deliberately delays its response to trigger a timeout. Asterisk use a network simulator asterisk tools like TC, traffic control, on Linux can be used to simulate network latency and packet loss, which can trigger timeouts. You can configure TC to introduce delays or drop packets for specific network interfaces or IP addresses. Asterisk test in different environments asterisk test your application in different network conditions, example slow Wi-Fi, mobile data, to identify potential timeout issues. 9. Conclusion. Handling browser timeouts effectively is a critical aspect of building robust web applications. By understanding the causes of timeouts, implementing appropriate error handling strategies, particularly using abort controller and promise.race with the fetch API, implementing retry logic, and minimizing the likelihood of timeouts through server-side and client-side optimizations, you can significantly improve the user experience and reliability of your application. Remember to test your timeout handling thoroughly to ensure that it behaves as expected in different scenarios.